Mr. Wright here. Welcome to this second film of IGCSE vector exam questions. These questions all concern proving that 3 points lie on a straight line, or in other words, that the 3 points are collinear. If you find the film useful, please hit like, give me some positive feedback. If you'd like to subscribe to the channel, then please do. Right, let's get on with the questions. Okay, here is the question. Have a look at it. First thing I'm going to do is I'm going to make sure that the information that I know, that I'm told, is reflected in the diagram. So I know that AB is 2, 7. So I'm just going to put a line there, and I know that that is 2, 7. And I know AC is 10, 11. Right, well, let's draw the line AC here. And I know that that is 10, 11. Okay. Point B has coordinates 5, 8. I've got to work out the coordinates of C. Right, well, to go from B to C, B to C, I want to do BA basically, and then plus AC. So that's going to be BA is minus 2 minus 7 plus 10, 11. So that is the vector 8, 4. So what are the coordinates of C? Well, the coordinates of C are going to be the coordinates of B plus the vector 8, 4, which is going to give me coordinates of 13, 12. So point C here is 13, 12. And that is part A. Have a look at part B. Now in part B, I'm told that E has coordinates 63, 211. And I'm asked to prove that ABE is a straight line, is collinear. Well, if ABE is collinear, then AB and AE must be related. AB must be a fraction of AE, or AE must be a multiple of AB. All right, so let's have a look at AB. Well, I already know that AB is 2, 7. So I really now need to work out the vector AE. Now AE, if I want to go to AE, then what I'll do is I'll go to AB, and then I'll go from B to E. Now I know AB already. AB is 2, 7. Now what about the vector from B to E? Well, B is the point 5, 8, and E is this point. So to go from B to E, I'm going to have to move x coordinate 5 to an x coordinate of 63. So that's going to be a horizontal movement of 58. And a vertical movement from 8 to 211 means I'll need to do a vertical movement of 203. So the overall vector there is 60. The overall vector there is 60, 210. Aha, well look at that. 2/7 is indeed a fraction of 60 over 210. So what I'm going to say is I'm going to say 60, 210, that vector, equals 30 times that vector. Therefore, ABE equals straight line. Okay, that's that question. Okay, question 23. OAB is a triangle. Now, there's no diagram drawn for me here. So the first thing I'm going to do is to draw a diagram and to write all the information on that diagram. So perhaps you should pause the film and try and draw the triangle yourself. Okay, so I've got a triangle and it has a point O here and a point A, and then it has a point B. Okay. So here's my triangle. So O, A, B. Right, OA is A. And OB is B. That's OB is B. Okay. C is the midpoint of OA. So those two sides are equal there. Good. D is a point on AB such that AD to DB is 3 to 1. D, 3 to 1. Okay. E is a point such that O to B is twice of BE. So BE is half of OB. Right. So what I need to do is extend this line here halfway. Okay, so that is where E is, where this vector is a half of B, because BE is half of OB. All right, what does it ask me to do? Use a vector method. Prove that the points C, D, and E lie on the same straight line. Okay, so there's the problem, there's the diagram drawn, and there's the problem defined. Okay, so how to solve the problem, how to prove that C, D, and E lie on a straight line. Well, what I'm going to do is I'm going to look at the vector C to D, and I'm going to look at the vector C to E. And if C, D, and E are on a straight line, then CD will be a certain fraction of CE, or CE will be a multiple of CD. So let's have a look at that. Now CD is simply from C to A plus A to D. Okay, well C to A is a half of A, and A to D is 3/4 of AB. Okay, well that's a half of A plus 3/4. Now A to B. If I was going A to B, I'd go A to O, and then O to B. There we go. Right, let's carry on simplifying this. 1/2 A plus, well, minus 3/4 of A plus 3/4 of B. So that is minus 1/4 of A plus 3/4 of B. Okay. Right, now let's have a look at C to E. Now, if I was going from C to E, I would probably go C to A plus A to B, and then go from B to E. Okay, well, C to A is a half of A. A to B, well, if I'm going A to B, I'll go A to O and then O to B, so that's minus A plus B, and BE is simply a half of B. Let's simplify that. You end up with minus a half of A plus 3/2 B. Well, let's look at my two resulting vectors there. I can see that CD is equal to a half of CE. So because CD is a perfect fraction of CE, then C, D, and E must be collinear, or CDE is a straight line. And that is my proof that CD and E lie on the same straight line. Mr. Wright here. I hope you found those two walkthroughs useful. If you did, please hit like and let me know. If you've got any questions or I wasn't clear, please leave a comment and I'll respond. The next film coming up in the vectors playlist is all about finding ratios with vectors, and these are the trickiest questions, I think, that appear on IGCSE questions with regard to vectors. So I'll leave you to get on with that one.